So now let us look at how to check the consistency using cramers rule. So here also we'll take two cases. That is, the first case is Ax is equal to B. The second case is Ax is equal to 0. This is an example of non-homogeneous equations. This is an example of homogeneous equation. So we have Ax is equal to B. So how do we check the consistency? First, by Cramer's rule, we know that x is equal to delta 1 by delta, y is equal to delta 2 by delta, and z is equal to delta 3 by delta. These are the formulas corresponding to Cramer's rule. Or we can also write this as delta times x is equal to delta 1, delta times y is equal to delta 2, delta times z is equal to delta 3. So now using these relations, we discuss the consistency of equations. The first case is if delta not equal to 0. If the denominator is not equal to 0, so you have unique solution. Because you get some values of delta 1, delta 2, delta 3. So x has a unique value, y has a unique value, z has a unique value. So delta not equal to 0 implies unique solution. So if delta equal to 0, now what happens? So if delta equal to 0, take the second relation. So if delta equal to 0, delta x is equal to 0, delta y is equal to 0, delta z is equal to 0. And if delta 1, delta 2, delta 3, if any one of them are non-zeros, then obviously x, y, z do not exist. Because if delta 1 is non-zero and delta is 0, so 0 into which number will be equal to a non-zero number? No solution. So if delta 1 is equal to 2, delta is equal to 0. So 0 into which x will give you 2. So there is no x which is possible. Hence, if any one of at least any one of delta 1, delta 2, delta 3 not equal to 0, this implies you have no solution possible. So if at least any one of delta 1, delta 2, delta 3 becomes non-zero, no solution will be possible when delta is equal to 0. And in the next case, if delta 1 is equal to delta 2 is equal to delta 3 is equal to 0. So if all the delta 1, delta 2, delta 3s are equal to 0. So this side is also equal to 0, this side is also equal to 0. Right hand side, left hand side, right hand side, left hand side, all are equal to zeros. So whatever x, y, z you put, so the right hand side and left hand side are turning to be equal. So if delta 1, delta 2, delta 3 are equal to 0, then there are two cases. It may or may not have a solution. I cannot directly say that it does not have a solution. So if delta 1, delta 2, delta 3 are all equal to zeros, may or may not have a solution. And if solution exists, then you have infinite solutions. That means it might have infinite solutions or no solution. So you have to go and check the equations. So if the equations become parallel to each other, then you have no solution. If the equations become coincident, then you have infinite solutions. So you just need to go and check the equations in this case. So let us take an example and see how to do that. So this is how you check the consistency using Cramer's rule. And for homogeneous equations, you can see that delta 1, delta 2 and delta 3 are automatically equal to zeros. Delta 1, delta 2, delta 3 are automatically equal to zeros, because if you take out one column of A and completely replace it with zeros, the delta will automatically equal to 0. So in this case, you have only two cases. If delta not equal to 0 implies unique solution. If delta is not equal to 0, then you have unique solution, and that solution will be a trivial solution or a zero solution, because delta 1 is 0, delta 2 is 0, delta 3 is 0. 0 by any non-zero number is equal to 0. So x is equal to 0, y equal to 0, and z is equal to 0 are the only solutions. And if a is equal to 0, delta is equal to 0, then you have infinite solutions. Or if delta is equal to 0, we say that a non-trivial solution exists. Non-trivial solution exists. So for a homogeneous equation, if a non-trivial solution has to exist, then delta has to be equal to 0. So here, this case does not arise, may or may not have a solution does not arise, because all of them are passing through 0, 0, 0, hence they cannot be parallel to each other. So if delta is not equal to 0, only 0 solution is answered. If delta equal to 0, apart from 0 solution, you also have other solutions. So that is the analysis for homogeneous equation. This is analysis for non-homogeneous equation. So you just need to remember them so that you can solve the problems very easily. So let us look at this sample question. So you have 3 equations with you. These equations have a unique solution if k is equal to what? So let us use our concept of Cramer's rule. So if the system of equations should have a unique solution, then obviously the determinant of the coefficient matrix has to be not equal to 0. So if delta not equal to 0 implies unique solution, right? So delta is 1, 1, 1, 2, 1 minus 1, 3, 2, k should not be equal to 0. So this implies 1 times k plus 2 minus 1 times 2k plus 3 plus 1 times 4 minus 3 is 1 is not equal to 0. So this implies k plus 2 minus 2k minus 3 plus 1 should not be equal to 0. So 2 plus 1 minus 3 gets cancelled. This implies minus k is not equal to 0. This implies k is not equal to 0. So that means as long as k is not equal to 0, system of equations have a unique solution. So that's the answer to this question. In this question, you're given a system of equations. You're asked to discuss the consistency using Cramer's rule. So to discuss the continuity using Cramer's rule, we just need to find delta, delta 1, delta 2 and delta 3. So what is delta? Delta is just the determinant of the coefficient matrix. 1 minus 3, 5, 2 minus 6, 10, 3 minus 9, 15, right? So that is equal to. So to simplify the determinant, you can also use your properties. So in the second column, you can take a minus 3 outside. The third column, you can take a 5 outside. So minus 3 times 5 times 1, 2, 3, 1, 2, 3, 1, 2, 3. So if you take a minus 3 outside, this is 1, 2, 3, 1, 2, 3. So obviously this is equal to 0 because all the rows have become equal, all the columns have become equal, hence delta is equal to 0. Now the unique solution part has been eliminated. That means this set of equations do not have a unique solution. Now the comparison is in between infinite solutions and no solution. So now let us find delta 1. So delta 1, you replace the first column with the constant matrix 4, 11, 12. The remaining are minus 3, minus 6, minus 9, 5, 10, 15. So again you take minus 3 and 5 common. Minus 3 into 5. So 4, 11, 12, 1, 2, 3, 1, 2, 3, again equal to 0. Because the two rows are again equal to 0. Two columns are again same as each other. Similarly, what happens with delta 2? In delta 2 you have 1, 2, 3, 4, 11, 12, 5, 10, 15. So if you take a 5 common from this, again this column becomes 1, 2, 3, again equal to 0. And delta 3, so replace the third column by 4, 11, 12. So 1, 2, 3, minus 3, minus 6, minus 9, 4, 11, 12. So again if you take a minus 3 common from this column also becomes 1, 2, 3, hence this delta is again equal to 0. So we have observed that delta is equal to 0, delta 1 is equal to delta 2 is equal to delta 3 is equal to 0. So what are the cases that we can have? So if the equations are consistent, so if consistent, then you have infinite solutions. If not consistent, again you might also have no solutions here. So there are two cases that might happen in this case. So if consistent, they have infinite solutions, and it might also happen that they are inconsistent. So we have to go and check the equations. So we have to check whether the equations are parallel to each other or not. So if you take the first equation, x minus 3y plus 5z is equal to 4. The second equation is 2x minus 6y plus 10z is equal to 11. So if you multiply the first equation with 2, you get 2x minus 3y plus 10z is equal to 8. So 2x minus 6y plus 10z is equal to 8. 2x minus 6y plus 10z is equal to 11. So you can very clearly see that these two are inconsistent with each other. So this set of equations have no solution. Thank you.